Hello guys, I hope you're doing alright, and here we are in a new video about logics. Okay, today we are going to continue with the topic of conjunction. Okay, remember that last week we were talking about what conjunction is. This is a word that connects two sentences, two statements, and it's the word and. Okay, when I say something like, for example, I have a dog and also a cat. So the word and connects the two sentences. All right. So now we are going to see some special cases where we have more than two propositions. So, for example, in this sentence, in this proposition, we have one, two, three propositions, and they are connected by the logical connective and, okay, the little mountain. Okay, so how can we read this? How can we read this sentence? This will be P and Q and R. Okay, so it means that we have three conditions all together. And this is the associative law of conjunction. Okay, okay, let's see some examples about this. Let's see the first one. So, for example, we have given the propositions, we have P 3 plus 7 equals 11. This is the first one. The second one is Texas is a country. And the third one, the set A, 1, 4, 6, and 8, is a finite set. So we have to find the truth value of P and Q and R. So we will see if these compound propositions by three propositions is true or false. We are going to find out, okay? So let's start little by little. Remember the truth table for conjunction. This is the same that I showed you last week, okay? With the proposition, with the word and, okay? So remember that when we have true and true, the result will be true. And the other options are going to be false. True and false will be false. False and true will be false. False and false will be false, all right? So let's see. Let's start with the first one. We have P equals is 3 plus 7 equals 11. So let's find out if this is true or false. Is that true? No, this is false because 3 plus 7 makes 10. This is not 11. So in this case, this proposition is false. All right. We already have the first one. Now, the second one. Q is Texas is a country. Is that true or false? That's false because Texas is a state. It's not a country. Okay, it's a state but not a country. So this is false. All right. Okay, and the next one says the set A 1, 4, 6, and 8 is a finite set. Is that true or false? Of course it's true, because we don't have ellipses here. So we have 1, 2, 3, 4 numbers. Only 4 numbers. So this is finite set because it's limited number of elements. All right, so this is true. Okay, now we already have the truth values of P, Q, and R. Now we can start solving the truth value of the three propositions. What can we do for that purpose? We're going to solve first P and Q. All right, what is P and Q? Looking at the truth table, P and Q, so let's see, P is false and Q is false. So let's see in the truth table. False and false will be false, all right? So the result for this will be false, will be also false, okay? So we already have this truth table. Now, the R truth table, the R truth value, all right? Let's see, we already have that R is true. We already know why, okay? This is true, so this R will be true. So, finally, we are going to find this result, P and Q, that is false, and true, the other truth value. So, false and true, what will be that? False and true, we go to the table, false and true will be also false, okay? So, the result for this operation, the result for this will be also false, okay? And this is our final answer. So this is false, okay? Now, let's continue with other example, okay? Other explanation, okay? Now we will see a new logical connective called disjunction, okay? Let's see what a disjunction is. So, for example, if we have two propositions, the first one is I'm clever and Q is you're strong, we can form a statement with the word or, okay? So it means that we have one condition or the other one. So I'm clever or you are strong. So there will be only one condition, or either the first one or the second one. Okay, so we have two conditions separated by this connective, the word or. Okay, remember that. This is different to conjunction, that is and. Now, how can we represent the word or? Let's see this. The word or can be represented by a V, like this, okay? So P or Q, okay? This is read as P or Q. Okay, so we also have a new truth table for P or Q, like with conjunction. This is something similar, but with different true values. So P or Q means P is true or Q is true, or both are true. We're going to see this little by little, okay? So this is the truth table that I was talking about, and the truth table for P or Q. What happens when the first one is true and the second one is true? P or Q, or, so true or true will be true. Look that all of the choices are true except the last one when both of the propositions are false. Okay, so if they are false, both of them are false, P or Q will be also false. And it doesn't happen with the other conditions. True or true will be true. True or false will be true. False or true is true. Okay? And the only condition when this will be false is when both of them are false. Okay? Let's see an example, but with mathematical expressions. Okay? We will see that this is not so difficult. Let's do it little by little. Don't worry. Proposition P minus 12 is an integer. We already have this. Q, 2 plus 4 minus 6 plus 1 is less than 0. And R, Vancouver is the capital city of Canada. So first of all, we are going to find what does P or Q say. So this is the last table that we saw, okay? The last that I show you here, okay? Or, this is the same. And here is the other one, the last one of conjunction with the word and. But in this case, we have, first of all, we're going to find P or Q, all right? So first, we are going to use this table. Okay, so let's see. P, the true value of P, minus 12 is an integer. Is that true or false? That is true, okay? Minus 12, all negative numbers are integers. The second one, 2 plus 4 minus 6 plus 1 is less than 0. Is that true? So let's see. 2 plus 4 will be 6, 6 minus 6 will be 0, and 0 plus 1 will be 1. Is 1 less than 0? No, this is false. 1 is greater than 0, so this is false. And the last one, Vancouver is the capital city of Canada. This is false, because you already know that Ottawa is the capital city of Canada. All right? So we already have the P or Q truth value. And the first one, this is very easy with or. We have to find that in the truth table. So P or Q, so let's see. We already have P and we already have Q, the truth value. True or false? Go to the table, disjunction with or. So let's see. True or false will be true, okay? Which is much different than when we have true and false. In this case, we have false. but we are with conjunction. Look that we have the V here. So true or false will be true. Okay, so the first one is true. All right. Okay. Let's see. For the second example, we already have the truth value of P or Q, but we need also, we are going to use also the proposition R, and here we have negation of R. So we already have this truth value, P or Q, but we also have a conjunction again. Can you see here? A new conjunction and negation of R. Okay, so we are going to see how can we find out this whole truth value by using this table. Okay, so we will see that in the second video. Okay, I hope you understood this, the first part. These are some examples of conjunction and disjunction, and now we will see how can we build a truth table for more than true propositions by using conjunction or disjunction. Okay, so see you next video. Bye bye. See you later.